Hello and welcome to the ninth lecture in chapter 22 in our comprehensive course on AI, ML and DS. Now, here we want to do detailed discussion about embedded methods. And in embedded methods for feature selection, we want to discuss three methods, one based on random forest, one based on XGBOOST and one based on lasso. So, in the end of previous chapter, I told you one important thing, that we have not yet introduced the random forest or XGBOOST. Even lasso also we have not done in detail, just a little bit required discussion was done. So first we will learn linear regression, multiple linear regression, then regularized linear regression, that is lasso, ridge and elastic net. Then we will learn classification. Then we will learn this decision trees, then KNN, K-means, then ensemble models like random forest and XGBOOST. So random forest and XGBOOST, they will come much later on, and this is just a small usage of random forest. So this is not exhaustive discussion on random forest algorithm. This is just discussing usage of random forest for this feature selection, right? Okay, so let us first import the necessary libraries. So from sklearn dataset, import fetch underscore California underscore housing, import pandas as PD. From sklearn.model underscore selection, import train underscore test underscore split, and from sklearn.preprocessing, import standard scalar. So these four you are supposed to import. Then once these are imported, then next step is loading the data. So data is equal to fetch California housing as frame is equal to true, and then df is equal to data.frame. So you will get your df. Again, this much I am keeping in one cell, and we would like to have a look at our df. Although we have done that many times, but this is how we progress in every problem now onwards. So we can see that our data frame consists of these many features, and this is our target variable, that is median house value, and each number is to be multiplied by $1 lakh. So 4.526 is $0.4526 million, right? Okay. Now, once the data set is loaded and this much is already done, then we will do this, that is dividing the features and the target. That means so far we are in this white stage. If I take this down, it would be more appropriate location for that. So far we are in this white picture stage. Full data set is loaded. Now I am doing this stage where I am splitting feature matrix X and target vector Y. So this is feature matrix and target vector, right? X and Y. Now thereafter, so X and Y are there. I can print X and print Y. And the rest of the things that I am taking in the next cell. So what these particular cell, these steps do, that convert this white colored black and white full data set into this green and yellow portion. So let us see what are these X and Y. Then you can see that now this is my feature matrix. It has all the features which affect this target variable, median house value, and this is the value of the target variable, which are in $1 lakh, multiples of $1 lakh. So 4.526 multiplied by 1 lakh, that many dollars, right? Now what we are doing again is we are converting this X and Y, that is green and yellow, also into this X train and Y train. So that is we are splitting green horizontally. Maybe 70% of the observations are in train set and 30% of the observations are in test set. Similarly, we are splitting this Y also horizontally, and 70% observations are in Y train and 30% observations are in Y test. So for that we use train test split, which we have already imported from sklearn, sklearn.model underscore selection, import train underscore test underscore split, right? So X train, X test, Y train, Y test. These are the four results which will be given by the RHS. What is RHS? We use the function train underscore test underscore split, and we provide capital X and small y, and then test size is equal to 0.3 and random state is equal to 42. Okay, so 30% observations are in test set and 70% observations are in train set. Okay, now if you do this, and I will here also print underscore train, then print x underscore test, then print y underscore train, and print y underscore test. Okay, and the rest of the thing, feature scaling, that I'm keeping in the same cell, but I don't want to produce any output of that, in which I am just scaling the two train parts, that is X train and Y train. Now what we are doing in this step, if you want to see, then in that case, if this is my condition at present, this, then I am converting this big green and big yellow into this stage. So that is X train is created, X test is created, Y train is created, and Y test is created, and I am printing them, and then I am scaling the two train, that is the two one green and one yellow, so that two green, that is the X train and X test, that those I am scaling. Okay, but this is the output of X train. It has 70% of the observation, or out of 20,000 something rows, 14,000 rows. This is X test. It has 6,192 rows, so remaining 30% observation. This is X test, and that has how many rows? 14,448 rows, and this is Y test, 6,192 rows, right? So this is how I have got 4 parts from my original data set here, and I have scaled X train and X test in the last step. So if required, I will use scaled version of X train and X test. If required, I can use original version of X test, X train. Now this much is common step, and we have done that many times. I have done it repeatedly again and again, even at the cost of or risk of finding myself repetitive, because actually this should become a reflex action. This is what we are supposed to do throughout our life now as a data scientist. So better to learn it properly. Now from this stage, it is algorithm specific. From sklearn.if, here I can say sklearn.linear models import linear regressor. Okay, then it will be a linear regression, but here I am writing from sklearn.ensemble import random forest regressor. So random forest is a much better algorithm. It works for numerical categorical variables. Of course, categorical need to be encoded. That is a different thing, but it works for them. Then it also works for classification and regression both. Okay, and it is very accurate, prevents overfitting, and it can have many more applications apart from doing regression and classification. For example, it can help in feature selection, which is what we are doing at present. It can help in plotting feature importance plot, which is also what we are doing at present. So from sklearn.ensemble, import random forest regression, create a random forest regressor object, and then fit that object on X train and Y train. If you want to use better result, you can use scaled version of X train. Okay, Y does not have any scaled version. That you should understand that we are scaling only X part. That is, this green part only is scaled, right? So that is why here there is no Y train scaled. So that mistake should not occur. Okay, so we are fitting our random forest model on X train scaled Y train. Y does not have any scaled version. Once it is fitted, now my random forest model is trained and ready. Now I can use it for any purpose. So here I am using for feature importance. Here I am not using it for predicting house value. I am just using it for feature importance. So it is rf.feature underscore importances underscore. And if I put that in a data frame, then it is this only, which is stored in a new variable like this, and that is converted into pandas data frame. Okay, so let us plot that data frame. Yes, here after the feature importances are converted into pandas data frame, we are also sorting them. Ascending is equal to false, means in descending order. So that means the feature which is having the highest importance will come at the top, and then second highest important will go below, and so on, right? And then we are plotting the diagram. So if you plot the diagram, then you will see it takes a little bit of time. On your laptop, it might take slightly more time. Now PLT is not defined. That is because I think from matplotlib.pl pyplot import PLT, that I have not written. Okay. So if you import matplotlib.pyplot as PLT. PLT is just a alias. Okay, and now that error will not come. PLT is not defined. So it is taking some little bit time because random forest tries so many decision trees. still SNS is not defined. I'm sorry, but because I'm starting this recording in a fresh beginning of Jupyter notebook. So import Seaborn as SNS. Now hopefully nothing will create trouble. Yes. So yeah, now you can see that these are my feature importance. This is my feature importance plot, and these are the features, and the bar length of the bar shows its importance. So originally, how many features were there? If I copy all of them here, then these were the features: median income, house age, average number of rooms, average number of bedrooms, population, then average occupancy, latitude, longitude. So this shows that among them, this is the order in which features are important. So if I now, it is very easy. If I want to select one most important feature and make a very simple model, though it will not be very accurate, because you can see that if that feature has 50% importance, means the other features collectively also have 50% importance. So this model, if taking only median income as a independent variable and median house value as the dependent variable or the target variable, will not be very accurate. But I can make a simple, very simple model with taking only one feature. Okay, if someone says make a model with two uh, independent variables, then I will take median income and average occupancy. If someone says select three most important features, then I will include longitude also, and someone says include four most important features, latitude also, and five most important features, and house age also. Okay, there is no point in extending beyond that, because these are total 8 features, right? So my purpose of feature selection is to make the model simpler. So out of 8, 5 say median income, average occupancy, that is the second one, longitude and latitude, these are the other two, and house age, that is this. These many features will make a decent model. Okay, now same thing we want to do by first, this lasso part we will do later on, but first we want to do by this XGB regressor. Now here also that first part would remain same. So I'm very quickly doing that, even at the risk of repetition, that from sklearn.dataset import fetch underscore California underscore housing. So you import the data library data set, import pandas as PD from sklearn.model selection, import train test split from sklearn.preprocessing, import standard scalar, import matplotlib.pyplot SPLT, and import Seaborn as SNS, right? And then data equals fetch underscore California underscore housing as frame equals true, and this BF is equal to data.frame, and then this is my data frame, entire data frame. So that is this white colored portion. Now I am splitting it into this green colored portion and this yellow colored portion, that is this X and this Y, right? So X is equal to df.drop columns equals median house value. Okay, so this median house value column is to be dropped, it has to be removed, and all rest of the columns need to be kept. So if you drop median house value and rest of the columns are kept, what you will get is this many columns and all the rows. So that will be my feature matrix, that is my X. And in Y, you just keep only median house value. So that is this only one column. So that will be my response variable vector. Okay, so I print them, and you can see that this is my X, capital X, feature matrix, and this is my small y, that is response vector. Now once these two are found, thereafter I am trying to split them. So if you split them, then here X train, X test, Y train, Y test, and thereafter it is train underscore test underscore split, capital X comma Y. So that is train test split takes what as argument? Then it takes 4 arguments. One, it takes the feature matrix. Next, it takes the response vector, and it divides these two into 4 parts. So X would be divided into X train, X test, and that will be stored here. And similarly, the small y will be divided into small y train, small y test, and they will be stored here. Okay, the remaining argument just show in what ratio you want to divide your original, these original. So I'm saying 30% will go in the test part, so that is by test size, and 70% that means will go in the train part, and the random state is just for reproducibility. So I'm printing this X train, X test, and all that. Let me clear first and then reprint it. And suppose for the sake of separation, I can add one such line. This means this much string, this string multiplied by 20 means attach same string, that is these only 20 times. This is a short and concise way of instead of that writing whole long like this. Okay, you can write somewhat this way, and that will ensure that all lines will have same length also. So you can see uppermost is my X string, 14,448 rows, 70% of the row. Lower one is my X test, 6,192 rows, 30% rows. This is my Y train, that is this rows, and again 14,448 rows, same as the X train. X train and Y train should have same rows, and similarly X test and Y test, they also should have same rows, 30% of the total rows, right? Now feature importance with random forest we have already done. So now our goal is to do feature importance with this XGBoost. So new line will be only this: from XGBoost, import XGBoost regressor and initialize one XGBoost regressor object with just one argument, some random state. Here also it was the same thing. From sklearn.ensemble, import random forest regressor and initialize random forest regressor object with some random state. Once the object is initialized, thereafter what you have to do is fit it to my scaled X train and Y train. Y train is never scaled, only X train and X test are scaled. Okay, so fit them, and then find the feature importance, because random forest and XGBoost, they are such two algorithms which have built-in mechanism that during training itself they create feature importance, and the way to get the feature importance is also the same for both. The trained model name dot feature underscore importance underscore. Here also you can see the trained model RF, that is the fitted model RF dot feature underscore importance underscore. Okay, so you have to find the commonality between various different things. Then you realize that this sklearn or entire Python is designed in a manner that is very user friendly, I mean programmer friendly manner. So you have to remember minimal thing. Only the import library changes. Thereafter the syntax, whether you are using XGBoost or whether you are using random forest, remains the same. Then you convert this feature importance is whatever you have got that are stored in this variable. You can store it, you can give it any name, EQ, XY, any name, and then you convert that into a pandas data frame with a column. One is X dot columns, so that means all the columns of the feature matrix. And what are those columns? Then these are X dot columns, right? So they will be one column of my this pandas data frame which I am creating, and other column will be the importances of each column or each feature which I have calculated here. Okay, and once it is converted into pandas data frame, I will sort it in descending order, and so that the most important feature comes at top. Then I am plotting. So this no module name XGBoost. Okay, so whenever this thing happens, what you have to do, that you know that sorry, I just moved it up. Okay, just do one thing: is install XGBoost, because if XGBoost itself is not present, then you cannot import it, right? So pip install XGBoost. Of course, internet must be on for this. It will take some time to fetch the library from the internet and install in my virtual environment. You can see that it is downloaded, collecting XGBoost, downloaded, and then installing collected packages, and now it has successfully installed. Okay, let me clear this output and make this a markdown cell, so that otherwise what happens is every time I execute this Jupyter notebook, every time it will try to install, and then it will say that the requirement is already satisfied. Yes, now XGBoost, once it is installed, it is working like a breeze, and it has given you this feature importance. You can compare here: median income, average occupancy, longitude, latitude, house age, average rooms and population, and average bedroom. That was by random forest. Okay, and by XGBoost, median income, average occupancy, longitude. So up to the 3 they are equal. Latitude, 4th is also equal. House age, 5th is also equal. Then average rooms, that is also the same. Population and average bedrooms. Okay. So here in average bedrooms and population, just order is interchange. Here population is having more importance and average bedroom is the least important. Here average bedroom is more important. But at least as far as top 5 are concerned, median income, average occupancy, longitude, latitude, and house age, that the two algorithms agree. And these are the two most robust algorithms of the Python ecosystem, right? The random forest and the XGBoost. So if they have agreed, you can very confidently say that if you make a model with these 5 variables, that would be a reasonably decent model, which will have high accuracy on the train and test both, and which will generalize well also, which will not overfit also, right? Okay. Now this is about the XGBoost. We have not bothered to introduce what is XGBoost. Remember, similarly, we have not bothered to introduce what is random forest, because as I said before that you have to do still some simpler algorithms. Then we can go to random forest and XGBoost, right? So now last embedded method for feature selection is lasso regularization. We have already done this about this lasso, that it selects the features by shrinking certain coefficients to 0, and I discussed also. So just a quick revision is due here. Now, for example, this is a multiple linear regression model where y is some response variable and y is equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. So I have to say kept first three here. So y is my median house value, that is what you are predicting, and x1 is my first feature, so that is the median income. So beta 0 plus beta 1 multiplied by median income plus beta 2 multiplied by average occupancy plus beta 3 multiplied by longitude, plus suppose there are more terms also, beta 4 multiplied by latitude plus beta 5 multiplied by house age plus beta 6 multiplied by average rooms plus beta 7 multiplied by population plus beta 8 multiplied by average bedrooms. So that was my original complicated model. But if I want to make this model simpler by keeping only these three, okay, only these three. So median income x1, average occupancy x2, and longitude x3. So only this much part I want to give. Of course, beta 0 will be there, but then for that I have to do the rest of the coefficients somehow 0. So that means there was one term beta 4 x4, where x4 is this latitude, but I should somehow reduce beta 4 is equal to 0. Similarly, there would be one term beta 5 x5, where x5 is the latitude, but again I have to take and make that term not latitude, x5 would be house age, so then that would be somehow its coefficient I would make it to be 0. Then beta 6 is equal to this average rooms, so then beta 6 is equal to 0, okay, and then beta 7 is equal to beta 7 is the coefficient of population, so somehow that also should be made 0, and beta 8, that is the coefficient of average bedroom, that also should be made 0. So in that type of case, if all these coefficients are all themselves 0, so in that case clearly x4, that is the fourth independent variable, or x5, fifth independent variable, or x6, sixth independent variable, or x7, seventh independent variable, or x8, eighth independent variable, that is this is my x4, latitude x5, x6, x7, and x8, right? This all would not matter then, or you can say that for all practical purposes my model has become simplified, and now it does not depend upon these parameters other than only for top three parameters. So if somehow I can reduce the coefficients of other independent variables to 0, then my model will be simplified and it will have only three independent variables, like this kind of model, okay, this. Then that process is achieved by what is called lasso. How lasso does it? How it shrinks its features? Don't worry about that part at present, right? So now again the initial steps are the same. I am doing it because I need to do that repetition once in a while, or this is the initial part of this real data science beginning. So I'm doing it again and again, and those who find it repetitive, please pardon me. But first part is importing all the libraries. Second part is loading the data set and printing it the data set. So this data set is complete data set with features and response variable, that is this y. Next phase is dividing the x and y into dividing a full data set into x and y. Green part is all features and yellow part is all response variable. So that is called feature matrix and response vector, and I am printing them, okay. And then now I am doing this from this step to this step, in which these two, big green and big yellow, are to be converted into 4 by horizontal splitting. So x would be converted into x train and x test, and y yellow would be converted into y train and y test, okay. So 4 outputs I will get. How that outputs are given by this function, which takes as its argument 1 x feature matrix, small y, that is response vector, the ratio in which, or the proportion in which test set will be created, so 30% or 0.3, and random state for reproducibility. So 4 things are produced: x train, x test, y train, y test, these 4 things, right? Okay, and I'm scaling these two green, x train and x test, yellow, that is y train and y test, they are not scaled. Now this much is repeatedly done. Thereafter, if you want to do it by random forest, feature selection by random forest, then the steps are these. If you want to do feature selection by XGBOOST, then the steps are these, which we have discussed earlier in this lecture. Now I want to do by lasso. So from sklearn.linear model, import lasso. You can also import, I think better perhaps would be LASSOCV also. LASSOCV is also there, yes. So that is cross-validated lasso, but fine, let us just do lasso. And lasso is equal to create a lasso model with certain value of alpha. Now this alpha is one specific hyperparameter for the regularized model like lasso. If you read its theory, then that will be called gamma sometimes in some theory books. So it is alpha or gamma, whatever you call it. but some constant whose value can be adjusted, 0.1, 0.2, 0.3, right there. So I am choosing 0.1 and I'm fitting that model on my trained X scale and Y trained. Y is never scaled, so Y train is also not scaled and Y test is also not scaled. And then this model also has its coefficient. So PD dot series lasso coefficient underscore and index is equal to X dot columns. So that will create one pandas series, and then from which I can select some features where lasso coefficient is not equal to 0, because I told you the basic mechanism by which lasso will work. It will make the coefficient of less important features to be 0. So x4, x5, x6, x7 and x8, their coefficient beta 4, beta 5, beta 6 and beta 7 and beta 8, they will be made 0. So I have to then find that features whose coefficients are not 0. So that is why I am saying lasso underscore coefficient not equal to 0, and I'm converting them to a list, and then I'm plotting that coefficient using a bar chart, and I can easily look at what are the most important coefficients. So median income is the most important coefficient, house age is the most important coefficient, all rest of them are made 0, and latitude appears to be important coefficient. Now I can change the value of this alpha to some say 0.2 and then try. Then you will see that only 1 is the important coefficient. So this alpha is measure of penalty, and that shows how many, if you increase its value, more and more coefficient will be converted into 0, and if you decrease its value, originally it was 0.1, right? So at that time with 0.1 you got 3, but suppose I want top 4 most important coefficient, so I am writing 0.05. I am reducing the value of alpha. So now you can see that these are median income, house age, latitude, longitude, and similarly I am writing suppose 0.02. You just have to play with values of alpha. 0.02 appears to be too less because it is now giving 4 and 3, 7. So maybe 0.04. Okay. Now that gives 1, 2, 3, 4 and this 2 slightly. So maybe I can think that 0.045 would perhaps give me, no, that are also giving 4 coefficients. So 4, 5, 4, 6. In short, you just have to go on playing with the value of this alpha 4, 7. And wherever that, okay, 0.044, 43, 42, still only 2, or sorry, only 4, 4, 0. For 4, 0, I got 4 coefficients, this many coefficients, right? Okay, so then 4, 1. Yes. So you can see that now I'm getting 4 big bars. So these 4 are clearly the important features, and the next bar is just appearing, average occupancy. So that is the 5th important feature, because others are still 0. Lasso have made those other coefficients 0, but this is still non-zero. So that appears to be an important feature. Okay. So that's how I can find 5 important features, and selected features are these. Okay. So I can make a simplified model with required number of features by adjusting the value of alpha. That was about feature selection. Okay, and now I will do part D of the chapter, that is model evaluation and validation techniques. I go to the beginning of the chapter. Then part A was creating new feature, feature engineering. Part B was data scaling and normalization. Part C was introduction to feature selection techniques. Part D was model evaluation and validation techniques, which we are now going to do. And part E is introduction to sklearn library. We have already started using sklearn library, but this would be a nice little introduction, because in all rest of the chapters, 7 or 8 chapters, we will be using sklearn in detail again and again and again. So model evaluation is just this thing, that once you have made your model, so far we were doing about feature engineering, feature selection, but in the feature selection, the 2 examples which we did, XGBOOST and random forest, there we ventured into this territory also, that is model creation, right, and training, and but we did not do any validation, because there our purpose was not to just see how accurate our model is. There our purpose was just to create a model. As a byproduct of the training process, the feature importance plot is given by XGBOOST and random forest. So that was our purpose. But now our purpose is that we will actually build the model and we will make the prediction also. And at that time, the question is how accurate is our prediction. So that part is called validation. So now we are conclusively and decisively, and we have entered into this region: model creation, training, validation. This part is left now behind us: feature engineering, feature selection, and this part is now our focus for many of the upcoming chapters, because model creation is not the simple thing. No, model creation can be done by linear regression, multiple linear regression. It can be done by lasso. It can be done by ElasticNet or Reach, or it can be done by decision tree, KNN. Then it can be done by k-means. It can be done by ensemble models like random forest or XGBOOST or many other different things, neural networks. So this model creation is another real important part of the whole data science life cycle. One important part I have done that was in between this data understanding, EDA, data visualization, and then before we go to feature engineering, here one important part was done, that is about statistics, statistical tests, and hypothesis testing. Similarly, that was theoretical or fundamental pillar on which data science is based. And then now this is practical pillar on which data science is based. How to implement those fundamentals for practical case by using code. That is what we are going to learn in the model creation. So that will require validation of models. So we should be clear about once model is created, how will you evaluate how accurate the model is, and model validation techniques also. Okay, so we will see this in the next lecture. Thank you and see you in the next lecture.